your warm-up for today is how do you know these two things are equal? So I want you to think about what we did last class, the solving, look back at those notes, refer back to those notes, ask each other around you, do you remember how to do this, things like that. Solve this equation. If you have space on your notes, you can use that. You can draw on your desk. You can write on a separate piece of paper, any of those options. I'll give you a couple minutes. Solve that, and we'll talk about how do you know the answer you got is the correct one, or how do you know that these two things are equal. Someone tell me what you got.
Two equals 2.
Say that one more time.
2 equals 2.
What does that mean? We talked about that last class. It's a specific type of solution. Someone said it before I did. Infinitely many solutions. Okay, and how do we know that? Did we check it? Did we solve for it? How did we get that answer? What did we do to get that? Cameron, walk me through, what did you do to get that?
First I was thinking like multiplying the 6 and then plus 1.
Okay.
And then the other parentheses.
Okay. And this one too?
And then combine 6 and 4 together. Or 3 or 4.
You combine these two to get what?
2.
2. And then?
And then the numbers 6 and 2. When I subtracted 2 from the right side and 4 to the left, because making 2 is 2.
Okay, so if we solved it completely, that would be one way to see this is infinitely many solutions. We get 2 equals 2, the variables cancel. Where else could we have seen this is infinitely many solutions? That's in your memory of last week. Somewhere else. Something that tells us at this point this is going to be infinitely many solutions.
Isn't it when it's on the same thing on both sides?
So if you see that it's the same thing on both sides, you could stop there and say it's infinitely many. So those are 2 reasons how we could know for a fact this is infinitely many solutions. Did anyone try putting numbers in to see if it worked? So I did that. I'm just going to show you that that works. So we had some equation, we had the equation, and I just picked a random number. I picked 5. That's the same number. And then I'll show you what this does in 2 seconds. I don't think I showed you this last class. So what I just went to is second math. In that option, there's an equals. When you put that in, your calculator becomes like a right or wrong machine. It will spit out either a 1 or a 0. 1, you got it right. 0, you got it wrong. So I put in different numbers just to see what would happen. me one again, and then I just kind of kept changing it to see would this always work. And I just keep getting ones. That means no matter what number I put in there, this is going to always work, which means it has to be infinitely many solutions. Every number you know possible could always work. One thing that the creators of this anyway, one reason they gave was really these are the same on both sides. They both have this +1 inside parentheses. So if we were thinking about that, like that's our variable, that's our x. And I'm just looking at these numbers. 6 minus 4 is 2, and then this would be like the variable that this gets brought over. So that is another reason why we know that works. Alright. So we're going to start this, but then we'll probably have to pause. So everyone should have notes in front of them that talk about literal equations. And if you had your phone out while you were finished, make sure it's completely put away, so not behind your computers, not on your desk, not at all. Starting now. Right, so if I asked you, what is the difference between it's raining cats and dogs and it's literally raining cats and dogs? What would you tell me? Anyone have an idea? What is the difference between these two sentences? Anyone heard that expression before? It's raining cats and dogs or something. What would I be referencing? What would I be talking about? This kind of only works if you guys participate. Otherwise, I'm just up here talking. You guys need this. I don't. Okay. So that would be, which would be? Literally. It's literally raining cats and dogs. There are actual animals falling out of the sky. That'd be a word. If it's raining cats and dogs, that's an exaggeration. There's not actual, but it's raining so hard it feels like it. So other literal exaggeration examples. So usually when you say I got your back, you don't actually mean this. Hopefully not. And then a little mouse. Right? But in math, it's a little different. It's a formula or equation that involves several variables where we solve the equation like a normal equation, but we are not getting a numerical answer. We're not getting an actual answer. We're not going to get x equals 2. We're just going to solve the equation like it had numbers, so actually solve it, but not get an actual answer. It's a little confusing. Great, so go on to the next page. So the same ways we solve a regular equation, we're going to do that same thing here. Distribute if necessary, combine like terms if necessary. Think about what you want to solve for, because that will help you. I'll circle, underline, whatever. Use your order of operations, and then we'll go. So we'll do this first example, and then we'll do the literal example. So this one is going to give, the questions on the right are going to give, on the left, are going to give you an actual numerical answer. The ones on the right are not. So how would I solve this? How would I get x by itself? divide both sides by 2. So that we get x equals 5. An actual answer, we could check it. But for example 2, we just have variables. We are solving for a specific variable, the h. We're trying to get h by itself. How would we do that? Think about what we just did. How could we do something similar for example 2? Would be the final answer, yeah. So we would divide both sides by g, and you would show that you're dividing both sides by g, so that the g's cancel. But m and g are not like terms, so we can't do anything with that. We would just have this equation, h equals m over g. That would be our final answer. There is a way to check literal equations, but it's a little confusing, so I'm not going to show you. But you would take whatever you get and put it back into the original, and then you have to do a lot of canceling out. It just becomes hectic. So I would say don't check yourself with these, but if you do want to see that map at this moment, I'm sure. Do we have questions on how we solve that, or that answer, or anything like that so far? We really just need to get in the mindset that these will not have number answers, and that's okay. Sometimes they don't. Right, example 3. We are solving this for x. Trying to get x by itself. What would we do first? Subtract 5 on both sides. And now this kind of looks like example 1. So we're going to take both sides and divide. Now think about what we just did. How could we use what we just did on example 4? If we're solving for x, we're trying to get x by itself. When you say put B under C, doing what operation? Dividing. Not dividing. What do we do here? Subtracting. So we're going to subtract B from C. However, B and C are 2 different variables. They are not like terms. So we cannot combine them. We just rewrite. Right? We still have to get x by itself. How would we do that? Divide everything by a. Again, not like terms, so we're just rewriting. It looks weird. It doesn't have an actual answer, but that is our answer. I should say an actual number answer. Questions on that one? Think about example 5. Now this one has numbers and variables, but our answer is also going to have numbers and variables. We were trying to get x by itself. What do you think the first step would be? Abir?
Or
Adding 6. But it's going to be this entire term. We want to get rid of that entire thing. I'm going to rewrite that down here. And since the 6 and the y don't have anything to do with x, we're going to get rid of the whole thing, add it to the other side. But these 2 things are not like terms, so we can't combine them. We would just rewrite. But we're still trying to get x by itself. What would we do then? Now when we do this, we did not do this in this last one because we only had variables. 3 goes into 6, so we're going to divide these separately. This 17 over 3 will not easily divide, so that's just going to stay a fraction. But 6 divided by 3 can easily divide, so that's going to change. So anytime a number can go into something else, you want to divide it separately. If it can't, then you can divide it all together. We're going to pause there for lunch and then finish when we come back. This one. And then do one of these. You guys do 7 or 8. 7, I heard. So let's do that one. Thank you for showing that. Everyone's late today. Okay, for number 7, think about what we just did for the previous example. It's going to be similar. But now this one is just variables. So how would we solve this?
C equals G over AB.
Okay, one step at a time. What would we do first?
Divide.
We divide first here. Think about what we did here. And what would we do here? Subtract CD. We have AB equals G minus CD. So kind of like the same thing as before. And then, I didn't circle this. We were trying to, I'm sorry. If we were solving for A or B, then yes, we would do this. So everyone erase what we just said. I wasn't reading. Because we're actually trying to get C by itself. If we were solving 8, then yes, we would have did the exact same thing. But because we're solving for C, you have to get rid of AB. So we're going to subtract AB. Right. And then if we're trying to get C by itself, what would we divide by? E. And here, because nothing else is a B, we're not doing it separately all at the same time. So C equals G minus AB all over B. Mac, make sure you're writing this down. Put your phone away. That was ones. Okay, questions on that one? Flip to the next page. Find any questions on this that maybe look confusing, you're not sure where to start, have questions about, and we'll go over any of those. Here, 4. If any others, let's do these first and then we'll go over more if maybe. Alright, number 2 is kind of like what we just did, but a little different. Because we have to get T by itself. We gotta get rid of this P just by itself. How do we do that? Up here, subtract it to the other side. And rewrite. Now, P and R and T are all multiplying. So we have to think of how we can undo that, but also get rid of P and R. Divide. And we can actually do that at the same time. Divide P and R at the same time. So then our equation, we have A minus P all over PR equals 2. Questions on how we did that, how we got that, anything like that? Did I not do any of those? One of these things. Let me find it. Just have them. Alright, well, I got Alright, number 4, we are trying to solve for M. So we have to get rid of B. How would we do that? Here. You said minus B. Okay. If I subtracted B, would that help me get M by itself? We would not divide, because we're already dividing, but the opposite. Multiply it by B. So when we multiply by B, what's going to happen is both of these are going to cancel each other out. Become 1. This is going to be B equals 10. And then that one. Questions on that one? Number 5. We're trying to get B by itself. So we got to get rid of C and we got to get rid of D. Which one do you think we're going to get rid of first? If I got rid of C, I would be subtracting. But because it's in the numerator, I can't subtract it just from this. I'd have to subtract it from the whole thing. That's not really possible because then I also this, and that's not so not C first, so D. And how would we get rid of D? Multiply. Same thing we just did. Multiply B on both sides. So this D and this D cancels, and this becomes AB. So we're closer to getting B by itself. What's our last step? Now subtract. AB minus C equals, and that would be our final. Questions on that one? 6 is a little weird because we have to distribute H, or maybe distribute H. So if we distributed H, we'd have H with B1, which is what we're trying to get rid, or get by itself, and then we'd eventually have to get rid of the H again, so we'd kind of be creating an extra step. So to avoid that, we're going to get rid of these two things. So here we have a fraction. We're going to take that and flip it, and multiply that on both sides. So that the fraction, bless you, and the 2 cancel each other out on one side. And now, again, we see the parentheses we want to distribute, but again, that would not help us. So what we could do instead is divide both sides by H. then the parentheses would disappear. Okay. Last step, how would we get B1 or B sub 1 by itself? Cameron?
Sharks beats.
I want you to look at the very last page and find any others you want to see you go over. And then after we do these, today is a short day, and then we'll be done.
Five or seven.
I'm going to say that 5 and 8 are very similar. They're just solving for two different things, so we don't need to do both of those. Any other people? Any others? 4. Start with those. If you have any others, we'll do that. So number 1, we are solving for t. Everything is being multiplied. How would we undo whatever to get t by itself? Here. So are we adding? We can't subtract. There are little dots in between all of these. We just don't see them, they're invisible. So if they are multiplying, to undo that we would do what? Divide. And we're going to divide I and R at the same time. So P over IR equals T. Questions about that one? Or we have to get M by itself. So think about some of the others we had to do. We have to get rid of the 2 and the B squared. Which one are we getting rid of first? We're going to get rid of that by multiplying, just as we have done before. So we have 2k equals mv squared. Okay. I'm going to give you a hint for this one. The v being squared, we don't have to do anything with that squared unless we were actually solving for v. So because we're solving for m, it can stay squared. So how would we get rid of v squared? So we're not going to do anything with that square. It can stay squared. We just have to get rid of it somehow. Think about what m and v squared are doing to each other. We have 2k over v squared equals m. If it asks us to solve for v, then we have to take the square root and it'd be a whole thing. But in this case, that is not the case. Right. Number 5. Does anyone still need 4 before we click on them? Right. We are solving for z. So we need to get rid of The 2a and the 9, the 3j and the 4x, we don't really have to do anything with them because they're already unused. What would we do? So if we are adding these two, how could we undo that? Subtract. So anytime you get stuck or if you're not sure where to go first, you can always look at the actual operation and undo it. So subtract 2a to the other side. So these are my z's, just so we're all clear. I'm going to put this in the front to make this ABC order. And then our last step. And here, because I could simplify this as a fraction, the 9 and the 3, we're going to do it individually. So divide each piece by 9. So z equals, this is going to remain a fraction, -2/9 a. Put the a next to it, or in the numerator, either or. 3 over 9 would simplify to 3 what? Say 1/3. So you can put 1 and then 3. Or you can put it as j over 3. Both of those are the same things. And then minus 4 over 9x. Or -4x over 9. Either way, doesn't matter. Do you have any questions on that one? Confused about anything so far? The last one, number 7. A equals what's supposed to be a pi symbol, r squared. We're trying to get r by itself. So we do this. Divide by pi. This is my pi symbol. Do however you do pi symbols. Now in this case, because we were trying to get r by itself, we have to get rid of the square. How would we do that? Take the square root. And we have to do that to both sides. So on the right, the square and the square root cancel each other out. But on the left, we just have the square root of a over pi. And that would be it. Questions on that, or other questions on this page or last page that we skipped over? So, for the remainder of class, I want you working on one of these 3 things. So 1, you have a quiz on Thursday on everything we learned. I'm going to explain how the quiz is going to work on Thursday. So I'm going to give you a study guide. Before the quiz, we're going to review. So you can be working on that, working on practice problems, referring to your notes, getting help, all those things. You have 2 Delta Math assignments due on Thursday. One is from the notes we just took from last class on multi-step equations with variables on both sides. The other one is your literal equations, what we just did today. So you have 3 choices you should be working on, one of those 3 or all of them if you so choose. Questions about what we're doing for the remainder of class? I'm going to pass out your